Alright, this is an example of applications of solving quadratics. This is a relatively simple one, but at least it will give you kind of the framework for solving these. All of them are different, however we can take some steps that are always the same. And the first step is obviously read it and look for some of the key words, like we have the word product, which means multiplication. We also have consecutive, meaning one right after the other, odd integers, and then is 43. So I think product is 143 is kind of important. The product of what? Well, the two odd integers. Okay, so we want to read it very carefully and look for things that indicate operations in mathematics. Alright, so one of the first things we want to do is we're going to define variables. And lots of times in mathematics we go let x equal, and then we say what x is equal to. In this case I'm looking for two consecutive odd integers. I got odd integer 1 and odd integer 2. So I'll just say let x equal the first odd integer. So some things I included in my definition for x are that it's odd and that it's an integer, so it's not going to be a fraction. As soon as I define that, now I have an expression I can write for the second odd integer, or the consecutive one, the one right after it. The next odd integer. And I have to go x plus 2, because odd integers are 2 apart on a number line, or 2 apart when we count. For example, if I start with 3, and I go to 5, I've had to add 2 to the 3 in order to get to 5. So I defined my two variables first, okay? And then once I've defined them, I start to look for clues inside the problem as to an equation that I can write. In this case, the clue is product of the two consecutive integers. Well, I've defined the two integers as x and x plus 2. It says it is 143. So there's my equation, and now it's just a case of solving that guy. So I'd probably distribute the x first. I would notice at this point it is quadratic because of the x squared in it. And so I would get it equal to 0, so I can use the 0 product property. And then I would try to factor that polynomial. Of course, if I couldn't factor it, I could try to graph it. Remember how we graph it, and if I did graph this guy, it would do something like this, and I'd be looking for my zeros. But rather than graph it and try to solve it, I'm going to try and factor it. Let's see here. I've got to get 143. And so I start thinking of things that multiply together give me 143, and I think 11 and 13 do. 11 times 13 is 143. They both have to be, nope. The 13 is positive and the 11 is negative. So that should be the factorization for it. I'm going to erase this graph over here. And so once I have it factored, I just set each factor equal to 0 to find out what x is. The first equation tells me x is 11. The second equation tells me x is negative 13. Now what is x? X is the first odd integer. That means my first odd integer could be 11. In which case x plus 2, the second or consecutive odd integer, is 13. So 11 and 13 is one solution to this problem. Those could be my odd integers. However, if x is negative 13, then x plus 2 equals negative 11. And so these two could be my consecutive integers, odd integers. And so my problem is now solved. I can say the two odd integers are 11 and 13, or they are negative 13 and negative 11. I don't know which the case is. That's the general method we'll use to solve these problems. Remember, read it, highlight, circle, whatever, any important words. Define your variables. State what x is, and if you write an expression like x plus 2, state what it is, and then try to write an equation based on your variables and the information in the problem. I hope that helps you. Our homework is from section 5, and all we had to do was the first 3 problems. I believe it's 221 through 223. So just those first 3 problems that will give you a little practice in solving this type of word problem.